Okay, let's try the 8.3 quick check. So these are elements and they're all in period 2, okay? Just trying to look, I haven't got a periodic table in front of me. Okay, but I knew that beryllium is element number 4, so 1, 2, 3, 4. I know that carbon is element number 6. And I know that fluorine is element number 9. Okay, so write the equation for the first ionization energy of beryllium. Okay, so I'm going to say beryllium, and this is a gas. And the reason is that if I want to remove an electron, okay, I'm talking about an isolated atom, so I would say beryllium gas. Be plus energy. Okay, it turns into Be plus and an electron. Okay, write the equation for the first ionization energy of fluorine. Okay, so fluorine, and then that would be a gas, okay, plus energy. Would it turn into fluorine plus an electron? So identical to what happened in beryllium. Now the idea here is that a lot of times students will go ahead and say fluorine forms negative ions, and it does, but that's not what the first ionization energy does. It forms a positive ion. Okay, of these 4 elements below, which has the largest atomic size? Well, trends, we know that as we go across, the atoms get smaller. Okay, so of these 2, I know that silicon is bigger than phosphorus, and same thing, germanium is going to be larger than arsenic. And going up and down, I know that they get larger because I have more and more shells. So germanium, okay, would be the largest of this group, and the idea is that germanium has the lowest Z effective and the most shells. So more shells than silicon, okay, and a smaller Z effective than arsenic. So we can see for each of those 2 trends, germanium would be the larger atom. Okay, of these elements, which has the largest ionization energy? Well, here it's a little bit tricky because we say, well, as you go across, they're going to get smaller atoms, and smaller usually means it's harder to pull off electrons. However, okay, we're talking about nitrogen family and oxygen family, and in nitrogen family, the electrons are coming from a p orbital, but it's a p orbital that only has 1 electron in it, whereas in oxygen it's a p electron with 2 electrons, so there's going to be electron-electron repulsion. So it's actually going to be a little bit easier to remove electron from oxygen than from nitrogen, and easier to remove electron from sulfur than it is from phosphorus. So these 2 are going to be a little bit more difficult to pull the electron than oxygen and sulfur. And of these 2, okay, the farther you are from the nucleus, okay, the easier it is to remove the electron. So since phosphorus has more shells, it's going to be easier to remove phosphorus. So the answer is going to be nitrogen, okay. And again, nitrogen here because nitrogen has fewer shells. Than phosphorus, which means that the electron being removed is closer to the nucleus. And because we're pulling from a p orbital that is half filled, then there's no electron-electron repulsion to help lower the ionization energy. So, and the electron comes from a singly filled orbital, I should say half-filled orbital. So that's not a great answer, but the idea is that nitrogen and phosphorus are more difficult than oxygen and sulfur, okay, because we're coming from a orbital with only one electron as opposed to the electron-electron repulsion we're going to get in the filled orbital. And the smaller the atom, the more difficult it'll be to pull off an electron because it'll be closer to the nucleus, and nitrogen is smaller than phosphorus. Okay, if beryllium turned into an ion, would the size of the ion be bigger or smaller than normal beryllium? Okay, well, beryllium, if you remember back here, has 4 electrons. And so normal beryllium looks like this, 1s2, 2s2. But Be would form a 2 plus ion, and that would just be 1s2. Okay, so will it be bigger or smaller? Definitely it's going to be smaller, okay, much smaller, because the idea that not only have we removed an electron so we have less electron-electron repulsion, okay, but we removed the whole, the outer electrons. So now the electrons that we have left are in the 1s orbital. Okay, 1s orbital is going to be much smaller than the 2s orbital, so definitely beryllium 2 plus is going to be the smaller ion. The Be2 plus ion would be much smaller than neutral beryllium. Anyway, that's the quick check.